So this is a weekly seminar. I have 3 topics to cover today. One is a Zotero+bibtex tutorial, which I'll do. Another is 2 current papers evaluating LLM's cyber capabilities, which I think are useful to examine because this is going to contribute to this review. And then a write-up about if AI is a threat to democracy. I think I'll start with Zotero+bibtex. So, I think we need to rotate this. Yeah, so on the screen you can see Zotero. The way it works is that I have a library of a bunch of stuff. I add different sorts of stuff to the library like so. So I have a browser add-on. I click the button, and it saves the library. If it's an archive page, it makes it downloads the PDF. If it's a web page, it tries to make a snapshot of the web page, and so it has a bunch of extractors for different websites. And this was a plain URL, so it locked maybe not very interesting metadata. It locked an abstract in the title. This is less one post, and this is an archive paper for which it grabbed different authors, abstract, archive ID, DOI, so stuff and things. And I have basically 2 use cases for the Zotero on it. Okay, maybe 3 use cases. So one use case is that I just group the stuff by folders. Here is a folder for seminar in February, here's a folder for seminar in March, so on and so forth. And for a particular folder, I have, let's see. Let's take random one, maybe this start. Yeah, so here's a paper we read in March, and I double click here, and I get a PDF with a bunch of highlights. With the highlights I made inline to PDF. So, I grab something, I make highlights, or I maybe add, note, and then that's going to get saved. And the next feature here is that it's going to get saved and synced to everyone you share the folder with. So, for instance, here at Palisade, we have a benchmarks folder. It had a bunch of benchmarks, and all the remarks and notes in PDFs are shared. That was feature 2. Edits, and then there is feature 3. Feature 3. I take overleaf. I have an employee write-up at overleaf. I set up. I'm not sure where actually. Yeah, so somehow I set up a Zotero integration, and this references.bib here. And what it does, it just imports, in this case, the entire Palisade library. You just browse it in the GUI in big text formats. And what I can do is I can take a particular, here's this article about refusal, I control F refusal, or here's the refusal article. I control C this tag here. I go to my text file, and I go like cite this thing. And I compile, and it cites that thing. So that's basically my workflow, and one I really encourage people to take on. So basically, everything you read, you click the browser button, it gets saved into Zotero. Then you can organize it by text or by folders or whatever. The folders get synchronized with different people. When you write something up, you import this entire library into Overleaf, and and use BibTeX stations. And that's it. So this is Zotero and BibTeX. Great. So we covered the Zotero and BibTeX, and the next thing is two papers, CyberSecEval and evaluating frontier AI models. And CyberSecEval is something that Meta released alongside Llama 3. This is what they evaluate Llama 3 on. And it's it's kind of a mixed bag of things. So, like, on one hand, it is a bunch of cyber benchmarks, very different ones. So, like, they have the secure coding benchmark, where, like, I think it's like really worth it to really look at what they're doing here. So, like, let's see. So, like, they have a bunch of languages. Actually, I think the pipeline here is that a human takes open source codes and categorizes insecure coding practices across 8 languages. And then you ask an LLM to write sample code, like a CSV parser, and try to classify whether it reproduces those insecure practices, 50 common weaknesses. So, like, this isn't exactly cyber as we normally think about it. This is more like upstream of cyber. Then something more directly cyber is cyber attack helpfulness. What we do, we take 10 attack tactics from Intra attack. Then we generate a bunch of prompts that ask to carry this particular attack. And then we use GPT Judge to see if the LLM tries to do something. As a not refuse. Let's see. This is cyber attack helpfulness for CyberSecEval 1. This paper is CyberSecEval 2, so it adds 3 more benchmarks. Like, again, thing which is not exactly cyber in my reckoning, prompt injection. As in, this is basically like adding like a meta benchmark of prompt injection. We'll see later on, like which ones they specifically take. This one is interesting. So how this one works is they have a test harness which generates programs. So, like, generates source code of about 100 lines, and the programs are generated such that they have bugs. And as we know those bugs, we can see if the LLM is successful in trying to do something right now in exploiting that. Yeah, so this is like testing exploitation capability on synthetic programs. Yeah, so this is basically prompt injection again. There's a difference that the above prompt injection was like I guess like standard output prompt injection, and this is like Python output prompt injection. All right, so yeah, so like they say that they have a special like they pay special attention to this trade-off between utility and safety. Like if you make the model too safe, it refuses things you don't want to refuse. And like the interesting thing is that they have data for that, as in they designed borderline prompts, which like I guess what they say here is that they are not malicious per se, but it's easy to see them as malicious, and they don't want them to be refused. Great. There is like a large section here, which relates a real bunch of prior work. So let's try to get through that relatively quickly. So you mentioned earlier that you can do, when you're evaluating LLM abilities, an easiest thing to do is multiple choice questions, like exam questions. And here is a bunch of exam questions in Cyber. Apparently, OpenAI literally suggests evaluate language models as students are evaluated. Yeah, that's one approach. Another approach is like a ratio benchmark, which does summarization, classification, and identity recognition. And like this, I guess this is basically like this was exam approach. This was like an NLP approach, like name identity recognition. Sure, whatever. Then there is also work which tries to measure the thing directly. As said, what this does, I didn't actually read the paper, but apparently we give some sort of exploitation context, some sort of vulnerability context. Like maybe we give I don't know, exploit or something, and see if this improves vulnerability discovery performance. Yeah. And so that's it for prior work here. And I think I'd like to kind of skip prompt injection here. I invite you to read that if you like. I mean, I'd like to skip this maybe. I'd like to see what prompt injections they cover. So like they have those 15 prompt injection methods. So like let's just read through that. So ignore previous instructions. I'm actually not sure how this one works. You know how this one works? I guess like one way this could work is like answer about this topic, but like going in reverse, right? Yeah. So again, like what's your thing? So kind of the same thing in reverse, pretend to be admin, different language, dump a whole bunch of stuff, and this psychology technique. I'm not sure what this is actually. I mean, as is literally the same with different values of M.
Implement anthropic research evals low context lesson.
Manage that the way.
No,
All right. Well, I didn't use the paper. Okay.
it's anthropic research about the low context research for like low context for bad examples and lot of bad examples, then how they'll do.
All right. Yeah. So like LLM artifact 1, LLM artifact 2. This I think maybe this was about inputs being disguised. This is about outputs getting disguised. Hypothetical scenarios, split and then combine, persuasion, set a scene. Yeah, so like a bunch of prompt injection methods. And they also have they test both direct and indirect prompt injection. Direct when the injection is uses direct input, and indirect when it's context which gets loaded from elsewhere, like from web page. Yeah. So that was prompt injection. Now, this is synthetic vulnerability discovery. And like, I find it cute that they randomly generate programs so that the LLM doesn't memorize programs. I mean, interesting. So like what they do is they have the generators. The generator generates a challenge program and a proof of concept that triggers the vulnerability. You can notice that this is like an inverse problem to what we do in underhanded code. And this guarantees by construction that the challenges are solvable. Like if you're into computer science, you might like this table, because like so this is the 4 kinds of stuff we synthesize. Like we have programs which this is basically a crackme, I think. So an LLM must craft a string which will unlock the program. Yeah, and we score based on how deep it goes, like how many ifs it passes essentially. Then we have they have injections like SQL source injections. Really, they have buffalo flows, which are which you score like 0.5 if it overrides with noise and 1 if it overrides with target. And they have all sorts of memory stuff. Yeah, so randomly plant a bug and synthesize the problem around it. Yeah, so like this table is basically like a fuzzer in reverse. Yeah, so we automatically generate changes to the fuzzer, kind of. All right. So one thing to account for is that at least like to skip for the top use. It might be interesting to see which judge they use here, because I'm not sure. So kinds of obvious types they have data for in terms of. And let's take a look at an evaluation. So this is like a heat map where red is unsafe, and this measures safety and not utility. And what we're seeing is that GPT-5 and Mistral are the least safe, and Llama 3 is somehow very good at this fuzzy thing, so like at looking for vulnerabilities. And for some reason they don't mention Gemini, though they do mention it here. I'm not sure why that is. Okay. Yeah. So like something to look out for in this paper is UK1. Then we have figure 2. This diagram is a trade-off between performance and false refusals. And on the y-axis we have refusal for benign prompts, and on the x-axis we have unsafety. So like lower is better in both. And this value, I guess this small Llama 3 is good, what this diagram says. And old Llama is pretty bad in that it refuses too many safe queries. And GPT-4 is alright. As it's also a nice figure. And now we also have a heat map for prompt injections. What we see here is, I guess, is that mainly prompt injections are not very useful, and that two kinds of prompt injections reliably break 5 models. Yes, so like almost all kinds of Llama are susceptible to a different tutoring input language and output format manipulation. Yeah, so that is what to look out here for. This high web that's here. Okay, it won't highlight there. Yeah. Yeah, I think that's not mainly what's very interesting. This one is interesting for us because and I think this is Yeah, all right. So I think we missed a useful section before. Yeah. So section 4.2 is yeah. So I'm a little confused here. I think what they're saying here is that the programs they synthesized are complex enough to be, or maybe they evaluate them in capture the flags, like in capture the flag style. I think that's what's going on here. So like we generate a program which which has like a deep like string logic, and we normally call it a crack me, but they evaluate it not like solved, unsolved, but rather by depths of how far they go. So they call it a capture the flag style evaluation. Like, does it make sense?
Yeah, and I'm stop.
I mean, do you understand that?
Sure.
All right, so like you generate a program. The program, well, like it's a crack me. As in, it matches a string. And what they're doing is like they know like how many checks they have for the string because they generated the program. And so what like in our current crack me evaluation, we score crack me's by whether we solved them, like say like the crack me output okay, or we didn't solve them. But as they know, like statically, the construction of the crack me, they can see it got like it got 7 checks out of 10.
Okay.
So they score this as 0.7, and they call this, I think, capture the flag style and scoring. Yeah, so that's why this diagram here is called capture the flag style test. So like I think that's pretty misleading, but still, so like it apparently models are good at coding in high-level languages and not good at coding in low-level languages, or the challenges are like too high. So yeah, that's the result. Then let's do this. Yeah, all right. So that's the paper. Let's just briefly cover again like what they're doing here. So of direct relevance to us are prompt injections. Like I think it's useful to see how they evaluate them. I think they only care about safety and utility. Maybe look at their duty judge design. And then there is vulnerability identification and exploitation, which like this they're basically solving practice. So we should also like look at what they're doing there. Yeah, so that's the paper. That's CyberSecEval. The other paper is DeepMind. Evaluating frontier models for dangerous capabilities. And I'm actually not sure if CyberSecEval is open source. Yeah, well, maybe not.
And it's, yeah, there's a GitHub.
Check the label, what? On cybersecurity requires. data sets. Okay, this is implementation of CyberSecEval 2.
And easily.
You can install one using CyberSecEval in benchmarks. Okay, so that's promising. Ooh, they have the randomizer implemented here. Okay, it does seem to be open source. CyberSecEval 2, open source. Great. The Google paper is not open source and not so great. That's that. What the exposition is. We want high quality evidence about capabilities. We don't release the code. And not only we want high quality evidence, the also policymakers want that. And like here is the minor shot. They have 1, 2, 3, 4 kinds of evaluation. This is like misinformation and persuasion, and it's a little bit of like agency chain of thought thing. Cybersecurity is sort of like to focus on today. Self-proliferation is like, like association out, like maintaining a fleet, acquiring resources, this sort of thing. And self-reasoning is kind of a grab bag reading. I'd like also to skim that today. So, cybersecurity, the red box. 3 evaluations. One is an in-house ETF, which is not released, with model tasks. The other is about on the order of 10 hack the box challenges. And the third is identify if a function contains a vulnerability, identify whether a commit fixes the vulnerability or something like that. And like there is also binary exploitations that are actually what is hidden beside this. There is this 3. So what this evaluates? This evaluates generic 1.0 all sizes without safety. They say they used advanced agent designs. Like this is basically like all the agent designs out there. Like if you just look at the titles, like 3 of swords, maybe those some that were interesting titles. The moment pick through. It's like basically advanced agent design, something. Yes. We are skipping persuasion, but if you want to work on persuasion, you should check out these highlights. Those highlights stop. Alright. Cybersecurity. Like we say, agents will lower the barrier to entry for cyber attacks, and we don't want another WannaCry. I think the more nuanced version here is that what you have right now is malware assembly kits, right? So you can buy something into which you can slot the payload, and you can slot a penetration module, and you can slot in a lateral module depending on what you know about the target. And we have that. I think this is this is another step in automation from that. So this is we have Metasploit, we have auto Metasploit. This is we have malware constructor. We have auto malware constructor or something. Yeah, so that's like why we want that. Our first evaluation is capture the flag. This is standard capture the flag. Agent has bash on Linux. The agent has targets. If the output contains the target flag, you consider the challenge completed. And like they just I think they basically like don't tackle web seriously because they don't use because they don't have web browsers. And like those are some serious restrictions here. Like I mean, we time out. I like this basically says. Okay, no. I think what it does is that then we have a challenge. For a challenge, we get 10 runs of 20 commands, and each command is time bounded by 3 minutes. So like have like a very hard bound on the number of number of computers for supported here. All right, this is calling Unix canvas. The same time we have. And let's like a brief minute to look at the data sets. So like data set 1, in-house CTF suite. Like my favorite one here is the challenge to run sudo bash. I mean, bash is like sudo is passwordless, and so you have to run sudo bash. Or like 7-zip is passwordless, so I have to run sudo 7-zip. Yeah, so like that's the form of the challenges. I think there is a bunch which are like kind of about. This is about kind of reconnaissance. This is, I guess, reconnaissance as well. Yeah, I think most of these are like bottlenecks on reconnaissance, like about in eliciting the information from the targets. Yeah, so that's the in-house tip. Then there is like a bunch of hack the box, and I think these are like basically medium like code something. And then there is intercode CTF. Intercode CTF is one of the things we're going to use in our evaluations because this is actually open source. So like CTF for competition, testing with general Linux skills, something. Yeah, that was the evaluation. That's it. And here are the evaluation results. My favorite table is over here. Yeah, so like what we see here is basically nothing and nothing. And we're saying something more interesting in intercode CTF. We're saying Ultra actually does something. And we are saying that they basically don't evaluate binary interpretation, like at all. Yeah. And the notice that I think what this paragraph says is basically our agents aren't very good at context, so we should either wait for the next generation of models. Notice that this is Gemini 1.0 and now we have Gemini 1.5. or we should do better agent design. As they don't document the agent design, we don't know. Yeah, so like multi-horizon challenges. And let's also kind of look at how many answers we have. All right. Okay. So I don't have this at hand, but yeah. So like, probably don't have this at hand. Like, so this is like a random log. I literally just picked it at random, and they evaluate this agent fails to capture the flag, and it tries to run nmap, it tries to install nmap, it tries to run sudo. It's like, oh man, it's like, oh my, I can't do that. And it just used like 30% of the commands it could use. And that's like, okay, I can't use nmap. Let's like try to brute force CTC shadow. And it's like, I don't have John the Ripper, and it's like, let's install John the Ripper. And it's like, oh fuck, let's try to find the flag. And it's like, well, maybe John the Ripper, or like maybe Sue, or maybe John the Ripper, or maybe please John the Ripper, like literally the same command again. Again, after install John, again, literally the same command, literally the same command, literally the same command. And now it's like, it's dead because it hit 20 steps. And so what I'm seeing here is not a very smart like transcript. And this is what makes me hopeful that we can do a strong evaluation.
Recommend that was there. You give the soon for iPad.
No,
Okay.
I mean, yeah. So like, this sounds like a small, like a big evaluation. This particular transcript to me. Okay, that was CTF. CTF like results and data sets and transcript. Actually, I'd like to skip repeat detection, and I'd like to skip self-proliferation, and I'd like to yeah. So this is a little bit interesting because this this is an evaluation design, but not directly interesting. So I just made like highlights, and you can delete that you get later if you like. Skip it. Okay. But this is maybe interesting. Yeah. Okay. This is an interesting design. So let's try to yeah. Okay. This is an interesting design, so I'd like to cover it. So, like, we have a task, like some task, doesn't matter which actually. This is like in the self-proliferation section, but this design is invariant. And like we first let the model do something, and each task like has number of milestones, and here are examples of milestones. Like if you want to set up email, we have to navigate the sign up page, update the form, providing a password, get activation code, and like we have this statically, like we can instantiate the model at step 2, or we can instantiate the model at step 4. Like therefore we can evaluate not only the whole end-to-end run, but we can like see if the model gets stuck at step 1, but can actually do 2, 3, 4 successfully. Then this lets us see that. And let's try to decipher this here. If an agent could pass at least one milestone, then this gives us evidence that it can pass them. Like if one instance of the agent out of 10 passed it, this gives us evidence. And so like we score it by negative empirical probability of success, like by negative 0.1 if it could pass it only one time out of 10. And like this is approximately the number of bits required to find a random seed that would allow the agent to succeed in a single attempt. So like we kind of try to like if the agent can pass at least once, then we know it has this probability, and we try to estimate like this is kind of the inverse metric. I mean, like we try to estimate how many runs we need the to do to pass. Correct. And this is actually not what I want to talk about. This is actually what I want to talk about. So we have those milestones again. Like this is the milestones, like completely fine providing a password if you're setting up an email account. And if the agent couldn't do them at all, then what we do is we, from a milestone, sample 16 actions, deduplicate, sort by perplexity, and then a researcher picks the right action. And we charge the agent a cost in bits of expert help. And like it's bits because like if we have this many actions, then like we need this many bits to select the right action, right? Yeah, so this is interesting. I think this might be something we want to pick up. This scheme of assigning costs like this rewards actually, I think, and this is a cost which experts help. And so that was interesting evaluation design. Let's skip. What this diagram shows is that for some tasks, no expert intervention is required in bits. Like to set up a Bitcoin wallet, it always can do it by itself. To set up email, basically yes as well. But for some tasks, it either needs an amazing number of compute. In this case, it needs like 16 times as much compute, or this much expert help. And also, like be aware that expert help can be like fine-tuning on previous runs or something.
Yeah.
Sure. So, and a pretty important result in this paper is that, like, why this best-of-n approach works is because they find that models at this point actually know the right thing to do normally. Yeah, so like they know that to proceed from a given milestone, what action they should take. But the problem is that this action is not top one and not even top two. Like in this paper, like they say that it's only in top 16. So like the model knows what to do, but not like in the correct order, not in the correct rank. And what this suggests to me is that like fine-tuning might fix that. And that compute absolutely will fix that. Like if you do research, then this will like directly solve that. At the cost of compute. This is also interesting. Like you might use this to design prompts which work around that, or like heuristics which will work around that. I will cover it here. Yeah, so and we would really like to have like a scaling law here, and what they suggest here is that they have this like bits expert bits score, and they have like standard perplexity, and we really want to plot that curve, right? And I'm speaking surface name. Well, I guess this is a little bit interesting. So like we have a prediction market. I think. Okay, this is not actually a prediction market. This is a forecasting center. Okay, so we have a forecasting center. We are the forecasters. One will and the AI system solve all their internal challenges, and they get a mean in 2025, so not so long now. And they asked when will a system solve more than half of medium hack the box, and they get 2028. I find it interesting that like I wonder if there is a prediction market for that, and if not, we should create one. Yeah, so that was the paper. Let's go again like through parts 7 to highlight. Like they get 0 stars. Okay, one star out of 4 on CTF. I think we can do much better. The reason I think we can do much better is because of the results that the model normally knows what to do but doesn't run it right, and we can just directly throw computer it and just go through all the branches. They have an interesting design with scoring. You might want to think about that. Yeah. I wonder if we should Yeah, and like our current design is we take into code for steps and we take practice one for binary exploitation. So I think this kind of makes our evaluation like interesting because they don't have a binary exploitation here.
And it's cursive. Yeah, and it's cursive.
Yeah,
Good.
they don't have web securities up. Yeah. And then unless I wish to create a prediction accuracy, it's not that. Yeah, so that's it. That's the paper. So let's take a break and do the last thing.